Welcome to another Mathnificent conversation. Today's featured guest is a sum of two cubes. We've already had the twin, a difference of two cubes, but today we're going to learn about a sum of two cubes. So I still have the first 11 perfect cubes listed that you should be memorizing and have stored in your brain. I also have the sum of two cubes formula. The way I remember it is this sign and this sign flip-flop. So if it's a sum of two cubes, it starts with the plus, but then the first sign in the trinomial is a minus. With the difference of two cubes, the binomial starts with subtraction and then everything is addition. So I remember the sum of two cubes as those first two signs flip-flopping. Okay, so let's look at some examples. So again, before we get to the examples, we have a perfect cube. Sum means plus, and another perfect cube. So let's factor x cubed plus 27. So we have x to the third power plus 3 to the third power. So that means a is x and b is 3. So if we follow our formula, x plus 3, x squared minus 3x plus 3 squared. So that's going to be x plus 3 times x squared minus 3x plus 9. And now we want to factor 3x to the third plus 24. I see a GCF 3. I'm going to factor a 3 out. And I'm left with 3 divided by 3 is 1 times x cubed is x cubed plus 24 divided by 3 is 8. Okay, after factoring out the 3, I'm left with a sum of two cubes. My first term is x cubed, and 8 is 2 cubed. So that tells me that a is x and b is 2. So we're going to follow our formula. X plus 2, x squared minus 2 times x plus 2 squared. X plus 2, x squared minus 2x plus 4. And now we're asked to factor 729 plus x to the 6. I'm going to rewrite this as x to the 6 plus 729 because addition is commutative. I can move those around. You don't have to follow the formula the same way, but we know we like things in proper notation. So I'm going to put it in proper or standard notation first. Okay, similar to in a difference of two cubes, any exponent that's a multiple of 3 can be written as a perfect cube. Okay, so 6 is a multiple of 3. So I know I have x here, and I'm going to have my cube on the outside. 6 divided by 3 is 2, so that tells me that I have a 2 as an exponent on the inside. And 729 is 9 cubed. So now I know A is x squared, B is 9, and now we can just follow our formula. X squared plus 9, x squared squared minus 9 times x squared plus 9 squared. So x squared plus 9, x to the 4th minus 9x squared plus 81. There isn't a sum of two squares, so x squared plus 9 is prime, and our trinomial that follows is always prime, so we stop right here. Our last example, factor 8x cubed plus 125. So let's rewrite so we know what's being cubed. 8 is 2 cubed, and x cubed is x cubed. And 125 is 5 cubed. So A is 2x, and B is 5. And we follow our formula. 2x plus 5 times the quantity 2x squared minus 2x times 5 plus 5 squared. So we have 2x plus 5 times 4x squared minus 10x plus 25. 2x plus 5 is prime. We can't factor it further. And of course, our trinomial is also always prime. I hope you've enjoyed this series on a sum of two cubes. Check out the difference of two cubes and the difference of two squares. And I look forward to seeing you in more videos.